morning, guys. Good morning, everyone. Okay, uh, let's start the class. I'm sharing the screen. Yeah, can you guys see the screen?
Yeah, we can see.
Okay, great. Yeah, today we are going to discuss about LSTM model. And before that, let me tell you, I am having a bit of a throat problem, cough and cold. So I'll be going little slow today. Please don't mind, guys. And also, this is a little bit complex topic, so it is better to go slow and then understand each part slowly in detail so that we have the overall clarity. Okay. Yeah. So I just want to say that in the beginning itself. All right, guys. Now, mm, okay. Yeah. So what have we discussed so far is RNN, and there are many important points in RNN that we should know, right? Yeah. So what are all those important points? First one is it is a sequential time series based model. Okay. Second, can you guys tell me what do you think are the important points in RNN that we should?
Feedback loop.
What is it?
Feedback loop.
Yeah.
Uses.
Feedback loop.
RNN is mainly
Only
used for
one.
text and time text.
Same, because it is having feedback loop. That is why it is called as recurrent. Right. It is the beginning or the start initial model for text kind of data. Okay. So right now we have many advanced models to deal with text data, right? Whenever we have text data, there are so many kinds of use cases. For example, sentiment analysis, classification. Classification example is you have emails you get, you classify if it's a spam or not a spam. That is one use case. Another use case is given input, somebody will ask the output to write story, right? And some information. Instead of Google, you want to just ask the model, right? So there are many types of use cases, right? And we have advanced models for all of these use cases. Right now, the advanced models are GPT models, Llama models. You might have heard about Mixtral, right? Mixture of experts, different types are there, right? You might have heard about these Chat GPT, Llama 2, Gemini. Okay, all of these are what? Large language models, right? Large language models. And these large language models are made up of multiple deep learning models such as RNN, LSTM, GRU. Actually, they are not made up of RNN, right? They are made up of many LSTMs and GRUs. Okay, but we have to understand why they are not made up of RNN, right? So, which is that they have a drawback of vanishing exploding gradient. Exploding gradient. Because of this, what happens? Model will have only short-term memory. Long-term word sequences, they are not, the impact of that will not be there at all because of the vanishing gradient problem. Okay, it is very, very important to understand this properly, right? Can anybody tell me what is this problem and how is this problem coming in case of RNN? We have derived this, right?
Can I?
Yeah,
Yeah.
please go ahead.
So, vanishing gradient is a problem is like when the gradient becomes very small. It happens because we consider all the previous inputs into while building
Yes.
the model, and if the gradient is too small on multiplying everything, it would become even more smaller. So there won't be any change in the loss with the change in the weight. So yeah, so that is I mean, that is called as a vanishing gradient descent problem. The same occurs if the gradients are going to be too large, then it is going to be exploding gradient.
Correct, correct. Yes, yes. So I will just summarize what she has mentioned in 1 minute. If we look at the architecture of RNN, when we actually try to visualize it properly, this is how the architecture is represented. We all know this, right? RNN, input, hidden layer, output layer, and hidden layer has a feedback loop. That is a simple representation. But what it means is like this. At time step 1, input, and then hidden layer, and then it will be connected to output. But again, in time step 2, the inputs will be connected, and the time step 1 hidden layer output will be going to the same hidden layer at time step 2. Similarly, at time step 3, at time step 3, time step 3, the third input will go to the hidden layer, and the previous time step hidden layer output will go to this current time step hidden layer. And then finally the output will come. Because in my example, I have taken only 3 words. That is why it ended with time step 3. If I have 100 words, it will repeat for 100 times here. Again, one more time step 4 will be there. And then I will have what is the input word at time step 4. Maybe it is what, right? And then that connection will be there. What will be represented in numerical, and then that will be connected. And then here also I will have these connections from time step 3. And then it will repeat until T4, T5, T5, T100. Okay, so now if I write the backward propagation, considering only three particular uh, time steps are there, just for the sake of discussion, right? Why I have taken only three is just because it will be easy to understand, right? So here, if we write that, uh, yeah. So backward propagation, we know that it will actually update the weights in order to minimize the loss, right? But loss depends upon the prediction y hat, and y hat depends upon this O3. That is the one second. Y hat depends upon O3 means the hidden layer output here. So you see this is yeah. Here y hat. Here I will get y hat, right? Y hat I will get here, which depends upon what is coming from here. What is coming from here is considered as O3. Somebody will write it as H3. That is still okay. Just to make it more clear, people will write it as H3. That is still fine. So I can write it like this. You call it as H1, or O1, H2 or O2, H3 or O3, whatever it is. Fine. Mm, yeah. So we know that the Y hat depends upon O3, but O3 means nothing but the hidden layer. In the hidden layer at time step 3, in the hidden layer at time step 3, I will get the input at time step 3 and the weights, and output of the hidden layer at time step 2 will also come to the input, right? Come as input to the hidden layer at time step 3, right? Hidden layer at time step 3 will get two things. One is x 1 3, other one is hidden layer 2 output. These both will go to hidden layer 3, right? That's exactly what I have written here. And the hidden layer will have weights as WH, and the input layer will have weights as WI, which are shared weights. So this is also an important point. Let us write that here. Shared weights. The weights are shared. Okay. Yeah. So similarly, we know that this one depends upon the hidden layer at time step 2. For this, the inputs are for this, what it depends upon is the input at time step 2, weights, and output from hidden layer time step 1 will go to this, right? That's why it depends upon this also. And then the weights. Similarly, for this, it depends upon first input, weights, and O0, we have taken it as all 0, right? Just to have the feedback loop generalized. And then we have WH. So this is how the dependency thing will look like. Okay, this is how it will look like. Now, I want you to know this particular derivation. Everybody should know how we got this. Exactly. Why did I take plus here? Why did I not just multiply everything? Why did I take plus here? So it's very simple. It's because if we look at the diagram again, that's why I've written this. I drew this diagram so that it's easy to um, always come back and visualize and see the connections. So this one depends upon this, right? And then this depends upon this, and this depends upon this over here, right? So there is an impact of the current time step on the output previous and the previous to previous also, right? So that's the first word that what is there, will that have an impact on the output, yes or no? The first word, because everything is connected, as you can see, the first
Yeah,
word
it
will
will
have an
have.
impact. Yeah. So if you want to know how the first word is impacting, then this is how it is. First word is impacting second, second is impacting third, and so on. So here, um, so y hat depends upon this depends upon this, and this depends upon this. That is how you will navigate. So if we see directly here, loss depends upon y hat depends upon O3, O3 depends upon O2, O2 depends upon O1, O1 depends upon WI, weights initially, right? Which means simply these particular, this particular impact along with the weights, what is its impact has been considered. And then this, everything will have to be taken into account. So this will impact, this will impact, this will also impact the final output. That's exactly what I have taken. Okay. From the first, from the output 3 and output 2 and output 1. Okay. Output 1 impacts 2, and then 2 impacts 3, and then so on. Output 3 is direct. Output 2 would impact 3, and then 3, like this, so on. So that is why we got this. And if you have more doubts, you can see the dependency graph, and from that you can derive this as per the chain rule. Okay. Now vanishing gradient came because if you see here, there are too many multiplication terms, right? For just for three words, and input text is only 3 words. For 3 words, I ended up having these many 5 multiplication of slopes. If this is 0.1, this is 0.2, and this is 0.15, then when you multiply everything, overall it will be very small, 0.000001, let's say, right? So the slope with which the weight will be updated will be only this much. Let's say from here you get only 0.0001. From here you get 0.00003. From here you get 0.001. So when you add everything, it is still a small number, and the slope is very small, and you have a learning rate. Learning rate into that slope will again be even small number, right? That small number you will take and you will update the weight. You will get the new weight. WI new you will get. WO new you will get. But that weights update is very small. Right? That is why it's called vanishing gradient, which means the weights are not updating much, and the gradient is getting vanished because I am having multiple gradients multiplied. When you multiply many decimal numbers, then it will become smaller. Overall, it will become small. So the gradient effect is getting vanished. The gradient is getting vanished. It's getting small, close to 0. Otherwise, you may have 10 into 20 into 30, which will become very big number like 6,000. It will explode. The slope will be exploding. So your updation will be exploding a lot. It will be tending to infinity. You can write plus infinity or minus infinity, whatever it is. Okay. And similarly, this is the main problem. Now, imagine you have 100 words. 100 words. So how many terms you will have here like this plus this plus this plus this? How many you will have?
100.
100 you will have. And in the last one, you will have 110, 105, whatever it is, 102. You will have 102. 102 terms you are multiplying. All are slopes, all are could be very small. So you imagine, and for the last term, which particular impact are you seeing for the last term? So this is the first term, second term, last term. Last term means
It is the first word.
exactly first word. First word will have impact on second, it will have on third, it will have on fourth, and until 100. All that will be captured, right, in the dependency as per the dependency, and you get that particular term, right? The last term, right? Which means what is happening for this particular term, since I have one or two multiplications I have to do, overall value will be very less, close to 0. Yes or no? Will be close to 0, right? Which means for the first term impact is almost negligible. It's close to 0, right? It's like the term is not even present. The impact of first term is not even captured in the gradient, right? Or very less captured. Similarly, impact of second term and third term. But we have learned that sometimes the first term can be very important to predict what will be there in the uh, word after, let's say, 200 words or 300 words. Because, for example, here it refers to France. France is the very first word. And we need to know it means what? It can refer to a building also. Let's say there is a building here, Eiffel Tower, right? According to RNN, since it has only short-term memory, long-term it will not even like doesn't have ability, so it will wrongly give the more probability that it belongs to Eiffel Tower, which is not what this guy intended, right? So that is the idea. Okay. Now we know the vanishing and exploding gradient. So that is why we needed something called as long short term memory, guys. LSTM. It is a very beautiful concept. We will have little bit of more mathematics here, but it is easy. I will make it easy, don't worry. We have to do is understand these things. Why are we having these mathematical parts, or why are we having it, and what are we having, what is there, why it is there, and how are we getting it, right? These are very important. Okay, why we already covered most of it, but I will again explain it. So again, RNN, let me also tell you. Yeah, LSTM stands for long short term memory, guys. Okay, long short term memory, right? So here RNN, we have already concluded long term memory will not be used by RNN. Short term memory, it is good. It is good. Like if you have a sentence only 5 to 8 words or 10 words, or even 20 words, it is fine. A sentence with 20 words you want to process, it is fine. But if you want to process a book, or you want to process 10-20 pages, RNN won't work. Okay. Now that is why people have invented this. So people started analyzing how do humans actually process text. How do we process text? So think about it. We read the text line by line, sequence by sequence. Forget about all strategies where people read two lines before, two lines at the end, and then makes that. Don't go all of that. We read generally line by line, word by word, line by line, and we make sense out of what we have learned. Okay. For that, we should have a memory, right? We will understand something. Let us say we are reading some text. One second. Yeah, let us say we are reading some text. Bharat was called as Sone ki Chidiya at 1500s, contributed greater than 30% of GDP worldwide. And then we have India is in best GDP growth. Like this, you have a lot of things. Okay, so now I have read all these. Let's say again, I will write in between. After colonization, after colonization, uh, we became poor nation. Okay, and then all of this is there. So we when we read this, we keep some things in memory. First is, yes, we are talking about country, our country, Bharat. We will keep it in memory. And then we are calling it as Sone ki Chidiya at 1500. So this also will keep in memory, because it is like we are talking about past, not right now. It is right now. It is not called this. This is past. We will keep this in our memory. This we were talking about our country. And then we are understanding of maybe this GDP also as a number. We will keep it as an important statistic. We will keep it in our number, in our memory. Right after colonization, we became poor. Right, this, and then India best GDP growth right now. This is present, right? And this is 1950s. I will write. Okay, this is also past, but this you will call it as recent past. Okay. So now if I ask you, hey, um, in this entire text, okay, I am having memory, but we are also keeping two types of memories. One is short-term memory, other one is long-term memory, or long-term context also you can call, because everything first you need to have it in memory, only then you can do something. Now let's see. First, what could be the long-term memory? Can anyone tell me here in this example?
Bharat was called as Sone ki Chidiya.
Yeah, yeah. So I can take this Bharat and was called as Sone ki Chidiya. Now I will connect these both, and also at 1500, 1500s, Bharat at 1500s, or you simply put it here at 1500. Right now again India at 1950s. It is not Sone ki Chidiya anymore. It is poor nation. Right now India now the best growing GDP of all countries. Okay, this is how we will be connecting things. This you can call it as short term memory, because this has been, now I will tell you why. This is short term memory. This one is long term memory. Okay, I will tell you why. See, when we read something, I'm reading this line, I'm reading this line, I'm reading this line. I will decide which one to remember, right? I will decide, okay, Bharat, I need to remember because obviously I'm talking about Bharat. Sone ki Chidiya is an important fact, so I will remember this. So when I am in this line, this is my short-term memory, because I am reading the first line right now. I don't know what is later. Later, when I read everything, then I will decide, should I remember this or should I forget this? Because I may be seeing other important facts later. Right. But now, as of now, I have decided to remember this, and I have decided to remember this. It's a short-term memory right now. And then later, I am coming here, I am remembering this. Right. When I read this, when I read this second line, I will decide whether I should remember this GDP worldwide. Yes, I should remember this. But should I forget this? No, I should not forget it. I should continue in my memory. I should continue in my memory. Therefore, what happens is, whatever initially we take everything in our short-term memory. Okay, we take in our short-term memory, and then later we decide whether we should remember it further or not. Some things we keep to decide. Some things we ignore. It's not required to remember in long term. This is required to remember long term, so I will remember. This one is not required, so I'll ignore. Okay. So it's like, for example, let us say now I'm reading this line. I'm reading this line. India is the best GDP growth 1950. GDP best I will remember in my short term. Sorry, this is the one. GDP best I will remember in my short term. Right? Is it important to keep it in long term or not? That I will decide after reading the further lines, or after seeing this line itself. That is how we process, right? Okay. And I can give you more examples. So, hmm. So I think everybody must have watched Bahubali movie, right?
Yeah.
Yeah. So in that, initially, who is the um, king or ruler, whatever you call it, that was uh, initially it would be that Shivagami Devi, right? Shivagami
Yes.
Devi. Initially, it was some guy who was Shivagami Devi's husband's elder brother, right? And then Shivagami Devi's husband won't get the king post because he is handicapped. So Shivagami Devi will get it. So now, is this a fact that has to be remembered in long term? You just look the
Yes.
chain of events. Yes, it is important, right? So now I will have long term. Yeah. After that, who becomes the king or the ruler? After Shivagami Devi, who becomes?
Mah- Amarendra
Bahubali.
Bahubali. Yeah, Mahendra.
Nah,
The older one,
he,
the
yes,
husband
yes,
of
yes. Correct.
Anushka. Yeah.
Hmm. I think does he get? Yeah, Amahendra Bahubali. I'll just write it Bahubali. And then who becomes?
Vallaladeva.
Correct. Yes. And then finally, Mahendra Bahubali, his son. Okay. So here, so initially king is Shivagami Devi. Okay. And then later on, it is she is not the king right now. It will be Amarendra Bahubali. Right. And then later on, again, it will be Ballala Deva. And then later on again Mahendra Bahubali. It is important to get updated. This should be updated. In long-term memory, it should be updated. Right? Because you're studying, you're watching the movie, you're watching the movie. In short term, many things will happen. Let us say there is a song getting played. Right. You're watching the song, you're seeing the scenery, you're remembering, you're processing the lyrics, right? You're seeing the images in and then scenery, everything you are seeing in short term, but you also have remembered this, right? You also have remembered that the she was the initially ruler, then this, till now you remember. And then there is a song, but you have this in your long term memory. It is important to have this in long term memory. Not everything is required. Before this there may be one song, before this there may be one song, right? And in that also there may be some lyrics. You might have forgotten this because you thought it is, you don't want to remember, it's not important to you. You forgot this. Somebody want to pay attention to everything, so they will remember, but most of them we will ignore that lyrics, right? But song that is playing right now, whatever song is playing, that will be processing, and the memory will be there fresh in your mind. After 30 minutes or so, automatically it will forget, and only this important points will be there in your memory, right? So it depends. What initially you will take everything into short term only, and then it depends whether you want to put it in long term or not.
Sir, if there is a reference saying the
Hmm.
this king or like this king has done that, so
Hmm.
which means like it will refer to the long-term memory, right? Like what is
Yes.
corresponding that?
Yes. So we have to analyze and decide what to have in long term and what not to have. Somebody will be good at it, somebody will be bad at it. For example, when I am seeing a movie, I may think, who cares who comes first, who comes second. I may not remember. Therefore, when the movie continues, I'll get confused. Who was there before? What is happening? I'll get confused. So it is important to know, analyze which one to remember and not to remember.
Yeah, got it, sir. So if it says the previous king, so the reference should be
Yes,
like which king, and
exactly.
you have to compare with that. Okay.
Exactly. Right now you are at this level. Somebody tells previous ruler. This means obviously it's about Sivagami Devi only. Right now, if this is what you are currently this is where the movie is running. Previous king means obviously this Sivagami Devi is the previous king or queen or ruler, whatever it is. That is why it is important to know the context, long-term memory. Now, if you see, if I ask who is the first ruler, obviously, um, LSTM can tell because it has long-term memory. It will tell answer as Shivagami Devi. But RNN won't be able to tell. RNN won't be able to tell. Only recent memory it will have. It will tell Mahendra Bahubali. Just very plain, simple example I'm telling you, just to understand RNN versus LSTM. Okay. Now I have given all this uh, example, or how do you call it, analogy, not to waste your time, guys, but it is important to have a proper understanding of how things are working, how LSTM was got planned to construct and to capture what. They simply want to capture these two things: short-term memory, long-term memory. And from short-term memory only, things will be transferred to long-term memory. Because when you read initially something, it will be there in your memory. It is always short-term. That is true in real life also. The human brain works always like this, short-term. And when you repeat things many times, it will go to long-term. Or when you consciously make effort to remember, it will go to long-term. Okay, this is the idea. And also we have when we process text, we see line by line sequence. We store things in memory which are important to remember right now, and then put them in long term also later. And then we form connections. Right? Without connections, it doesn't make sense. Story doesn't make sense. Right? If I store in memory Bharat at 1500, a poor India. But if I don't have connections, then Bharat at 1500 was poor. If I say, it is absolutely wrong. There should be a connection that it is called Soni Ki Chidiya when Bharat was at 1500s, early 1500s, for example. Actually, it's not even 1500s, guys. Sorry, to be historically correct, at thousands, because after 1000 AD, that's when all these invasions happen, right, from multiple places, and then that's when all the this one money got looted and all, everything was looted. Anyway, just a small thing, but the idea is to understand the concept. Okay, now this is what it is. So let's see some diagrams of LSTM, guys. One second. This one I'll take it later. And this is important. See, nothing to get worried by looking at these complex diagrams. It will be, I will make it intuitive, because the reason it is important to know all this is, like I said, right now we are obviously every market is dealing with advanced models like this. And I'm telling, for these, the base is RNN LSTM models only. Therefore, I think you can understand how important it is to understand this properly with full clarity. Okay, so we will understand this properly. Yeah. So look at this diagram, guys. I hope this is clear for everyone. RNN, this is the simplest representation. But what does this represent? What is the meaning of this? Is we have seen in the previous class, right? Where I have morning, just before now also I was showing, time wise, there will be connections like this. Time step 1, 2, 3. This is the hidden layer. That's what the feedback loop represents. So simplest is, input will go to the current state, and previous state's hidden layer output will go as input to the current state hidden layer. And now obviously you will get output from this hidden layer. Okay. Yeah. Now there are two differences between, majorly two differences. Majorly, I'll say two new things got added in LSTM. And what is called as LSTM? Long short-term memory. Okay, majorly two things got added, which are another loop and different gates. Gates within units, another loop, and this is for long term. This is for long term. So just think about it. Why did we add another loop over here? That is because we know that RNN fails in remembering, or RNN cannot capture the long-term dependencies because of vanishing gradient and exploding gradient. This is the representation of RNN. Right now, the text is getting processed only in this direction. Right, input is going here, right, to the hidden layer. Weights are there. The operation is multiplication. Everything is happening. I'm getting output from the first time step hidden layer, which process the input. From the input processing, it got it, and then that is going to second time step hidden layer, along with the second time step input. Everything will be processed, and you will go here. You'll go here. So what is happening is processing of input is happening in one direction, and because of the nature of RNN, which is vanishing gradient and exploding gradient, long-term dependencies will be forgotten. It will not have a much impact on the final prediction. So what people have thought is, let us have one more parallel loop, right? And let this continue, and we will decide, okay, when we know that, okay, this is something important to remember, but this is initially, so therefore it may get forgotten. So therefore, let us save it in this particular another loop. And then maybe one more, let's save it. And then maybe one more, let's save it. Like this, one more loop has been created, which they call it as long-term memory loop. Long-term memory loop, or you can call it as long-term memory sequence, like this. See, it is a loop when you represent like this. It is a sequence when you unroll it like this. Right? Everything is same. Okay, don't get confused when you read the terms in a book. Different books have different representations. So I'm telling everything. Okay. Yeah. So what is the idea of this? Because RNN forgets the long-term memory, and we know that we need long-term memory, we're having a new loop called long-term. And from short-term, like I said, we read things in short-term. 1 second. We remember things in the short-term and decide what to save in the long-term. Right? For example, initially king was Shivagami Devi. Later on, we saw in the short term that ruler was 1 second. Initially, king was Shivagami Devi. Or I will write ruler. And then in the current short term, you are seeing ruler as Amarendra Bahubali. So initially it was this, and then what will happen? This will automatically be forgotten. It will automatically be forgotten by the RNN, because the current short term is this, right? Now LSTM will decide whether this information should be part of long term or not. According to if we just use common sense, then it is important. So therefore, what LSTM will do is, it will update, it will forget that the ruler or the king is Shivagami, and it will update that it is Amarendra Bahubali. Okay, it will update. Again, later that also will be forgotten until we have Ballala Deva and Mahendra Bahubali. Now, till now, it will get updated one by one, right? But if you want the model to remember everything as first king, second king, third king, fourth king, then that also can happen, right? That also can happen, like ruler 1, ruler 2, ruler 3, ruler 4. Why is it important? to remember all of these? Because somebody might ask the sequence, right? Shivagami Devi, Amarendra Bahubali, and Ballala Deva, Mahendra Bahubali. This is how the sequence was. Like this also, long-term memory can be saved, right? The point I'm trying to tell is, in long-term memory, in long-term memory, either you can add new things or you can forget forget something that is existing, right? These two things can happen within long-term memory. Okay, the reason is, see, there could be many examples. Let's say one more example I will take. So I will write that Ravi is good in studies, right? He works hard 12 hours a day, and then he goes for running, thus meditation to keep mind active. He indulges in ice creams. Today he went to ice cream shop, had butterscotch ice cream, but he wanted chocolate ice cream, right? And then later there are many pages about his daily work routine. Like he plans schedule, wakes up at 6 a.m. Before 10 a.m. he revises everything, and then lots of things about how he studies. It's lots of plans, strategy, everything. So until now, what happens is this ice cream is part of long term. It's part of long term, right? And then that he's good in studies, and then he is doing running, he's doing meditation, right? And then more things, his strategy. Before 10 a.m. he will revise everything, his strategy plan. He follows spacing technique. It's a technique to study and remember things quickly, all of that information. So as time goes, it is understood that it is not important to remember this thing, what ice cream he ate on a particular day, butterscotch, something like that. It's not important, because compared to all this, it's not that important. At least we can forget the flavor of that particular ice cream. Maybe just ice cream is okay, or we can totally forget this, because ice cream was written only one line, but the remaining um, let's say 90 lines or whatever is about his study strategy and how he's focused and what he does and everything. Okay, so this is not that important. So I'm not telling because only one line it is there, it should forget. No, because this is not that important compared to the other, compared to the existing information what he's talking about. So initially it will be part of long term memory until here, but as we read further, we will forget what ice cream he had, because we are focused on his strategies, how he's getting marks, how he's improving his mistakes, right? And how he is very disciplined, how he is actually avoiding social media, how he is very self motivated. All those things we're reading. Obviously we will forget about which ice cream he ate. It's not important to remember. It's not at all important, right? Initially, until we saw first four lines, okay, we will think, okay, he eats butterscotch ice cream. He ate, maybe he likes ice cream a lot. Maybe there will be a lot about ice cream he will talk. So let us keep it in memory. We will keep it in long term memory. But as we proceed further, we will totally forget. We will remove it from long term memory, right? So these things do happen. Therefore, it is important to forget things in long term memory and add new things in long term memory, right? As we read more, many things we have to keep adding. Okay, so that's why we have this particular loop. We added this one more loop. Second is, we have this important thing called gates. We have these gates. What are these gates? These are these gates. So have a look at this, guys, once. This is the RNN, and inside RNN, in the hidden layer, we can use tan H or sigmoid. In the output, we are using sigmoid, right? And this is a simplified representation of the hidden layer. Um, Right. See this, we know this. Where is it? Yeah. This one. Sorry. Think we had it as that day. We had the diagram, right? Where this was going to this was going to this. So what does this represent? This is actually like this one input. This is input. This is this hidden. Okay. When I say this like this, input is going to this. What it means is this, right? In neural network term.
Yes.
Yeah, this is clear, right? Okay. And then you are getting something out. And then this is going here. This is x2. X2. Okay. And then here this is going to this. So this is at time step 1. This is at time step 2. Time step 2 I'll put here. Time step 2 is getting x2. Okay, fine. And time step 2 is getting this also. Hidden layer at time step 1, T1, T2. So this also. Okay, and then so on. And then so on. Nobody can draw this like this much. Right. Therefore, this simplified representation is used. So whenever I draw this, you should be able to clearly understand that this is what I'm meaning. This is the connections, how they are. This is what I'm meaning. Okay. Yeah. Right. Now let's come back here. The same is happening with LSTM, guys. Same is happening with LSTM. Only thing is we're having one more loop. This is a loop, right? This is a sequence actually going like this, connection, and so on. But it's actually when you represent like this, it is a loop. You have only one hidden layer. You don't have these many hidden layers, right? You do not have these many hidden layers. It's only one hidden layer because the weights are also same, right? You have only one hidden layer, technically speaking. This output, this hidden layer feedback of the previous time step t minus 1, t. Okay, I'll put it as ht. No. This will be this. Yeah, ht. We have this loop. Okay, now I'm telling I'm adding one more loop. One more loop. So I'll have one more in parallel like this, right? Yes.
Yeah.
See, just the diagram. Same. One more loop I'm adding, which is having this hidden layer again and this input again. Okay, but the weights will be different, obviously. The weights will be different. Right? The same hidden layer. This goes to this. So again, how would I put this? So again, connection. Okay, different weights. Guys, is it clear so far? Getting confused?
Manikant,
Yeah.
the weights of the long-term memory is going to be the same on all the for
Yeah.
all the inputs, and the
Yes, it
weights
is
of
shared.
the initial feedback loop is going to be same. You mean to
Yes.
say the weights different is like for the long term it is different and for the hidden it is
Yes.
different.
Yes. Correct.
But the same weight is going to be shared for all the layers, right?
Yes.
I'm sorry,
Yes.
for all the inputs.
Correct.
Yeah, okay.
Yeah. The reason is we do not know how many words will be there, and if there are many words, you will have those many uh, weights. It'll explode. So that's not how it works, right? You will have only shared weights.
Yeah.
Okay. Yeah. So I'm telling all of these reasons also. When people ask you in interview, you may think I know this, but I'm not getting. So you will forget. Just like short term, long term memory, you will forget. So if you want things to go to your long term, you should write notes. Whatever points I'm telling which are important, you feel, write notes. Here I've written important aspects of RNN, right? Shared weights, sequential, feedback loop, But why? Why are these shared? Why do we need a time series based model? Why is there a need of feedback? Right? Why is it forgetting long term? Why are you getting vanishing gradient? Everything you need to know why. So, right, it's everything one line answer. One line answer for all of these. If you understand everything properly, you can write the answer in 1 to 2 lines. Okay, so you should make that notes. Already I'm writing these notes, but what happens is your own notes, if you write from your own understanding and your own language, it will be stored very strongly in your memory. Okay, yeah, now let us continue. I think the first point is clear. Second point is we are having gates. Why do we have these gates? It is to decide what to remember in long term, what to forget from long term, right? And what to continue in the long term. Okay, so where do I write this? Second, guys. Yeah, we have these gates to decide what to add in long term, what to forget we know in the long term, what to continue in the long term. From where? From short term. Okay. Yes, that is the whole point. We have this complex architecture just to achieve the long-term memory in simple terms. And we want long-term memory so that the text is processed completely and learned properly, so that models can answer much more accurately in better way. Fine, you can see all these forget it and all these. Okay, anyway, so in RNN it is very simple. RNN is very simple. You see here, I have this. I have this. This is what represented like this. See, oh sorry, this is LSTM. RNN is RNN is like this. It has only one something called. You can have anything right here. See, in the particular here, any activation function you can have. Activation function you can have tan h, sigmoid, ReLU. You can have anything. Sigmoid is yeah, you can have anything. So that's the only thing that is represented here in that particular hidden layer. Hidden layer is sigmoid, and going to output layer again. Output layer also taken as sigmoid. In that example, okay, you can take anything. Nobody is restricting you that you should take sigmoid only everywhere. Yeah. In case of LSTM, it is more complicated like this. Like this. So we will have to see things one by one here. First let us understand this. Understand this. So here I have so many things. First, see each and everything. This means plus. This means simple arithmetic plus, guys. Arithmetic plus. This is like simple multiple. It's not dot product. Okay. Multiplication, like the vector element level multiplication. I will tell what it is. Multiplication. Tan h, you know, right? This is sigmoid. This is tan h. This is sigmoid. This is sigmoid. Right? xt. xt means what? xt means what?
The current input.
Yeah, at time step t. Yeah,
Time
correct.
something here.
Yes. And ht you're getting, which is the hidden layer output. This everything is called hidden layer. Yes or no? This everything is hidden layer at time step t. And this is a hidden layer at time step t minus 1 is hidden layer at time step t plus 1, and they are connected. They are connected, and they have two layers, two loops. See, two loop. One is short term, other is long term. Other is long term. For short term, you don't have any gates, computations or everything. From short term, values are going to these gates, which means from short term memory, whatever words are there, whatever numerical representation of the words are there, is going to this operations. And using these operations, calculations, and whatever, that result is going to the long term. that result is going to the long term loop. Yeah, which means from short term, there is a decision that is being made using these particular uh, operations to decide what to add in long term, or what to forget in long term, or what to continue in long term. Okay. Yeah, and see, this is I don't know why this is like this, guys. It's actually, where is it? Yeah, two, 1 2, short term, long term. That's why you have two. Okay, everywhere they're connected. Yeah. Now let us see things one by one. Actually, they should be having better representation of these gates. So just give me 1 minute, guys. I will just search. Yeah, here we have. I think this is good. And 1 minute. CT. Yeah, yeah. Okay, it's fine. Okay, this is beautiful. I will take this also. Save to photos and save to photos. Yeah. Yeah, so just by looking at the diagram, can you tell which is for RNN, which is for LSTM? Simple, straightforward, right? Can you guys tell me?
Both of our
First one is RNN, one input.
First one is RNN
RNN. Second
because,
one is LSTM.
correct, exactly.
Okay.
The reason is because,
One loop.
Two
yeah,
loops
in the
only.
hidden layer, I'm having only one activation function, tan H I'm using. In the this hidden layer, I'm having many gates being used, and I have this one,
Long-term short.
long-term memory. Yeah, so LSTM RN is how on a very high level it will look like. Okay. Now, this one. Yeah, I can go with this one. Yeah, first. So actually, there this entire thing you can divide into three parts, guys. This entire what I mean is here what you see. Okay, let me first put everything. Yeah, so now we will have to understand how the gates are working, right? So we are coming to the most basic level working of LSTM, the most basic level which gives LSTM the ability to have long-term memory and decide what to keep in long-term memory, which is this particular operations. And here there are many things, right? We can divide this into three parts, actually. Three parts. This part, let me draw this, actually this part from here to here. This is not good. Here to here is one part, and here to here is another part, and the remaining is another part. Okay, so this part is for deciding if okay, one second, guys. Hmm. This So this part is to decide if the model has to forget anything in the long term. Forget anything in the long term. And this part is to decide if model has to add anything in the long term, right? Input, okay. It's called as input. It's not adding, it's input. And here we will see this part is to actually give the output from that particular hidden layer. Okay, so we will see all these one by one. So one by one, I have taken this, and this here. I will also write this down here, guys. So this is input forget get. Input get and output get. Okay, now let us understand each of these gates one by one. First, we will see the formula. As per this formula, what is it saying? Okay, and also let's see one. See, guys, I have told you about these operations, right? Just one more important point I will just add, and then we will go to the formula calculation. Yeah, so I have told you about these operations: sigmoid, tanh, multiple element multiplication, addition. I've told you these. There are other terms also. Actually, you see here. You see this other terms. CT minus one, HT minus one, HT, right? So this HT same. Now, what is this HT? Let me write this here. This HT is
Hidden
Hidden
layer.
layer.
correct. At T step. Okay. CT, what is this CT? This is,
Long-term memory.
yes, this is also called as cell state. Okay, cell state at T step. T step. Okay, now we know that for at time step T, this hidden layer will get input from um, will get input from this the
The
input
current
input
and the
text.
previous hidden layer.
Yes, correct. Input text at time at T step, right? This is one input. This is previous hidden layer output, and previous cell state output will be going as inputs. These are the inputs, right? For the hidden layer at time step T. And these are the outputs. Short-term memory, long-term memory. Correct? So I told you that two loops are there. One loop is the short-term, that is hidden layer output will get passed on to next hidden layer at time step T and so on. And the long-term memory also will be passed on. That's what we added, right? The long-term memory at the previous hidden layer T minus one time step will be passed on to the current hidden layer T step. Long-term memory will be passed on. So I'll write this also, guys. This, oh, sorry. This is okay. This is obviously hidden layer output at T minus one step. Okay, so now you must be familiar with these terms. This is obviously output. Hidden layer output at T step, cell state output. Okay. Fine. And all intermediary stuff you can see, these are just notations. FT means whatever you get output out of the sigmoid that you call it as ft, and you pass it here and so on. So here, if you see this directions, everything you see from this, you can get the formula anyway, right? So which means here first initially this and this. So can you guys guess what does this represent?
It's
What does
nothing
this?
but the simple RNN.
Current
Sigma.
step input and previous hidden layer.
Yeah, the simple RNN.
Correct, correct, exactly. So that is the simple RNNs, and after that, whatever output you get. So here, what happens is the input goes to the hidden layer time step t, and hidden layer time step t minus 1 will also go to hidden layer t. And what will be the output size you will get? Okay,
0 to
yeah, let's,
Yeah,
for
yeah.
example, let's take input size. Sorry guys, 1 second. Okay, now I will also take this, just a minute, duplicate. Okay, let's start with first one. We know xt, this is xt. Okay, and ht minus 1, this is, oh sorry, I'll take this as ht minus 1, guys, just for understanding. Okay, here you have, this is ht minus 1, this acts as ht minus 1, right? This is what it represents, right? xt, ht minus 1 going to ht, xt and ht minus 1 going to ht. Okay, and out of this, okay, now tell me what will be the h at time step t output, what will be the output dimension? Output dimension. What is the dimension of this vector? This is a single vector, right? 5 cross 1, right? 5 are there. 1 cross 5, how do we write it? 1 cross 5. 5 cross 1. Okay, now what will be the output you get from this? Output size. See, from here you will get a number, let's say 3.3, 2.1. And from here you will get 0.7. So the output is a vector. Exactly. 3 cross 1. Why? Because I have 3 neurons. Hidden layer, I have taken 3 neurons. So obviously out of this hidden layer, I will get three individual outputs from each of the neuron, right? Combined together, it is called as a vector of dimension 3 cross 1. So in this example, 3 cross 1 will be the hidden layer output dimension. Fine. In my example, this one, if somebody is taking 10 neurons in the hidden layer, what will be the dimension here?
10 cross
10 cross 1.
Yeah, because every neuron you will get output, right? From the connection. So here you will have multiple weights, whatever it is. Doing all the calculations, you will forward propagation, you know, we have learned forward propagation. Forward propagation we have seen. And the sigmoid I am taking here. Sigmoid activation function. Sigmoid activation function. Okay, I'm taking that. So that is being taken. So now whatever you get, iska sigmoid you take, sigmoid will always be between 0 to 1, right? So 0.9, 0.7, 0.03, something like this, you'll get it output. Sigmoid of this. Yes, just as an example, I'm writing, guys. Okay. Now this is, till now we have seen this. Yeah, now what happens is this one will be taken as a function of yes. Yes. Okay. So observe this. From forget get, you got, let's say this one, 0.9, 0.5, I will write 0.03. So let me not change it, 0.7. Okay, forget get, this is what you got. Forget get at time step t. Okay, I will put that also. Now this, I am telling you, has to be applied this function with ct minus 1. And we know ct minus 1 is nothing but long-term memory till t minus 1 step, right? And ct minus 1 might be having, let's say, values like this: 30, 100, 30. Just for example, I'm telling this is what it is. Now, when we do these both, this is nothing but element-wise multiplication. So 30 into 0.9 is 27. This into this, and this into this, 70. And this into this, what will be? It will be 9, right? Or 0.9. 3 by 100. No, 1 second. It is 0.9, right?
0.9.
Yeah.
Yeah, 0.9. So this is, sorry, this is CT. Okay, you see here. Not completely. This is so far. This is not CT. This is intermediate. It's intermediate result. So what happened is initially at CT minus 1, CT minus 1, you had this. Which means in the previous state, long-term memory had this. Later it got decreased, which means something got forgotten. Something got forgotten. And that was decided based on short-term memory. Based on short-term memory. Because forget get FT output. FT, how did you get? FT you got from sigmoid of the current input taken in and the previous input. Previous inputs meaning through hidden layer was also taken. So I'll draw this also here. Okay, both were
Means,
taken.
output of current hidden layer output. Sigmoid of current hidden layer output. Is it?
Yes, exactly. Yes,
Okay.
sigmoid of this. When you take, and why are we taking sigmoid? Can anyone guess why are we taking sigmoid for the forget get?
Because it is a binary class, right? Whether we need to remember or forget. Only
Yes,
two.
yes, because we always get in terms of probabilities, whether from 0 to 1. 1 means remember, close to 0 or 0 means when you
Forget.
multiply, it will be forget. If you have 0 here, 0 into 30, you forgot this stuff. You forgot. It's totally unimportant to remember. You forgot this stuff, right? And also, guys, it is important to know that all these will have same dimension. Otherwise, you cannot multiply, right? So FT, CT, HT, CT minus 1, HT minus 1. What else you will have? T, XT. XT is different. You can ignore it. So all this will be same dimension, obviously, because you're doing multiplications. And here, how many will you have? How many ever neurons you have in the hidden layer? That will be the dimension. right? Number of neurons. Here also, this also, everything will be same. You just think about it, you will understand. FT will be same because anyway you're getting FT from hidden layer output only. FT is nothing but sigmoid of HT. Cell state will always be from long-term memory. We know is always from short-term memory. Short-term memory is nothing but output of hidden layer. Output of hidden layer or a dimension is nothing but number of neurons in hidden layer. And previous also same. Previous hidden layer also has same number of hidden layers, same number of neurons. So everything will be same, right? But XT will be different. XT can be anything. It could be 5 cross 1 in our example. XT minus 1 will be same, right? XT plus 1 will be same, right?
Yeah.
Yes.
Yeah. So I'm trying to cover everything here because I don't want you to later get fully confused. See, there are so many things happening here. So it is easy to get confused, but you stick to what few things, and that from that few things you can derive other things. That way it will be easy. Why is this not? Okay, so you stick to few things like this diagram. You remember everything else you can derive. Okay. By the way, there is also something long term which I did not draw here. There should be long term connection also. Let's see this. Let's be there. I don't want to get confused. What's the time right now? Okay. Yeah, so it's already 10, guys. So let me pause at this step because next two will be little bit more complex. It's easy. It's easy only, but still, there will be few more aspects happening. But overall, it is easy. When you get the meaning, it will be easy. Don't worry. So we'll continue this in tomorrow's class, right? So guys, as you're seeing, I'm going it step by step. So it is taking some time to understand all these. Today is what day? Today is Wednesday, right? So ideally, I thought I will finish the entire thing by tomorrow, Thursday, but we may have to extend till Friday. And if you want me to cover PCA and then auto encoders also, then we will have to extend till Tuesday. If it is fine, then let me know, I'll continue. Otherwise, I will stop the class at Friday because you might have other classes also. And there should be a time it has to be finished. So it's up to you guys. If you guys let me know, I will take a call accordingly. Yeah, we have time. Don't worry. You can let me know by tomorrow or Friday. And then accordingly, I can continue, decide to continue or not continue. Yeah. So tomorrow's class.
We
Yeah,
have
just one.
discussed that one session for discussing all the ML means which is better in which situations.
Okay. Yeah, okay. I forgot about that.
Manikan,
Yeah, sure.
is it
Yes.
possible to have any one project in this one?
Project,
Can you
yes,
show us
have.
like, yeah,
Yeah, it would be fine. Good. Like if you share any project.
projects?
Yeah, project you will be having. I think there will be another faculty who will be taking the project. I'm not sure who that is because my dates are a little bit occupied from next week, Wednesday, Thursday. So I'm already extending because I want to because I have started this. I want to finish completely so that you will have one kind of a style of learning, right? So I finish this projects. If I take up, I will take up maybe after 1 or 2 weeks. It will be too late for you. So I've asked the other person to take care. But one important thing I want to tell is, LST. Tomorrow we will cover LSTM remaining, and RNN we will see code, RNN code and LSTM code we will see.
Manikan,
Yeah.
if not the complete project, at least the one which you have done, you can show that. So that we'll get an idea like how things are happening in the real world.
Sure. Yeah, we will do that. We will do that.
That would really help us. Yeah.
Sure. We will do that. Okay, no problem. Yeah.
Also, can you please share this notes today in the that we have seen today in the drive, please?
I will share it. Sure. I will share it. And is it clear so far what we have discussed?
Yeah, very clear. Yeah.
Okay. Yeah. So I suggest please go through this blog also. Very, very useful blog, guys. This guy has explained as much as possible very well. We'll put that in chat box. Wait. So my job is to just simplify things for you. I will read multiple resources, multiple videos. I will write my own notes. I will verify myself. I will do everything and make sure I give you the proper clarity, right? And simplify it. But obviously you can see other resources also. Please check this. I have put it in chat box. Please check this. Read this once. Before tomorrow's class, read this and make your own notes also, guys. Okay. Otherwise we'll forget everything. So many things are there. Okay, fine. All right, guys. Thank you. Then see you tomorrow, everyone. Bye, guys. Thank you.